Hello learners, today we are going to discuss a grade 9 integrated science paper 1 that the Kenya National Examination Council issued to all head teachers in junior schools and instructed them to give it to the learners so that they see the structure and the tricks of answering questions at the end of the year in the incoming national exam. So in this video, we are going to revise this paper in full. And this paper contains two sections. We have section 1, which contains multiple choice questions, and then we have section B, which has structured questions. So we're going to see what are these multiple choice questions and what are these structured questions. But again, in this video, we're going to see the simple tricks that we can use to answer all the questions correctly and accurately for you to score 100%. So let's begin with section M, which is a multiple choice questions. And the first question reads, during a lesson to identify common hazards and their symbols, learners observed various symbols. Which one of the following symbols observed represent a corrosive substance? So we want to identify a symbol that represents a corrosive substance. So before we identify the one which represents corrosive substance, it's very important for you to know each and every one of these symbols represent. So in this case, the first one is a flammable. It represents a substance which is flammable, or sometimes we call it oxidizer. Oxidizer. Then the second one represents a substance which is corrosive. This one is corrosive. Then the third one represents a substance which is irritating, irritator. So this is an irritator. Then the fourth one represents a substance that is an organ damage. So it's a substance that can damage an organ. Then our question was asking, which of these symbols represent a substance that is corrosive? So in this case, our answer is B. B represents a substance that is corrosive. Then the second question, during a group discussion, learners listed the following as the benefits of studying a subject. So the first one is to understand nature. Second one is to strengthen one's faith. Third one is to improve one's behavior. Fourth one is to solve problems in our daily life. Then the question is, which two are the benefits of studying integrated science? Before we answer this one, it's very important for us to know the definition of integrated science. We define integrated science as the study of 5 basic natural sciences, which are physics, biology, chemistry, earth science, and astronomy, and how they overlap and how they help us to solve our daily life problems. So in this case, let's see each of these qualities and what they represent. The first one, to understand nature, because in integrated science we study the natural sciences, so this one is for integrated science. The second one, strengthen one's faith. This is not part of it, so this is religious education. Then improve one's behavior. This one is also religious education. And then the fourth one is to solve problems in our daily life. This one is integrated science. So in this case, our correct qualities is for 1 and 4th. So in this case, our answer is this B, where we have understanding nature and also solve problems in our daily life. Then the third question, during a science lesson, learners discussed chemical symbols of the following elements. We have sodium, nitrogen, aluminium, and silver. Then the question is asking, which one of the following sets shows the correct chemical symbol of these elements? Then in this case, we have to identify the correct chemical names of these elements and their symbols. So in this case, we are going to begin with hydrogen. First one is hydrogen. Hydrogen, its chemical symbol is capital H. Then the second one is nitrogen. Nitrogen, its chemical symbol is capital N. Then the third one, 1, 2, 3, is aluminium. Aluminium. Aluminium, it is chemical symbol is capital A, small l. And then finally, the fourth one is silver. Silver, its chemical symbol comes from a Latin name, which is argentum, whose chemical symbol is Ag. Therefore, in this case, we are looking for the element whose symbols is H, N, capital A small l, and then capital A small g. Then in this case, the A, H, N, small a, capital small l, in this case, this one disqualifies A. Then B, H, G, this is for mercury, so this one is also disqualified. Then H2, this for hydrogen gas. In this case, we have hydrogen, so this one is also disqualified. And then finally, D, H, N, capital L, small l, then A, G. So D is our answer. So the fourth question reads, substances in nature exist as either elements or compounds. During a lesson, learners classified substances into elements and compounds. Which one of the following pairs of substances consists of only compounds? So we have sets of substances listed, and then the question wants us to identify a set that consists of only compounds and not elements. So before we answer this question, then we must know the difference between an element and a compound so that we can distinguish them. So in this case, let's define an element, and then we define also a compound so that we see the difference. So an element is defined as a pure substance, which cannot be split into any simpler form by any chemical mean. So these are substances which you cannot split in any simpler form by any chemical mean. While a compound is defined as a substance made up of two or more elements, which are chemically combined. So for us to know the difference between an element and a compound, an element is a pure substance, and this one consists of a substance which you cannot split into any simpler form by any chemical mean. But a compound is a substance which is made up of two or more elements which are chemically combined. For us to identify compounds like the question requires us, then in this case we must see the substances that we have and what they are made of. So we are going to begin with the A. A contains copper. The symbol for copper is Cu. So this one, it consists of only one element. So in this case, this one is not a compound because for a compound, it must have two elements. And then for iron, the symbol for iron is Fe for ferrum. That is the Latin name for iron. Then B, the symbol for iron is Fe, so it's also an element. And then water is H2O. So this water now is a compound because it has two elements. Then, so B has one element and then it has a compound. Then C, water is H2O, and then carbon dioxide is CO2. So in this case, we have two compounds. One is water, which has hydrogen and oxygen. These are two elements combined. Then carbon dioxide, we have carbon and oxygen. So this one is a compound. Then the last one is copper, which is Cu, and then carbon dioxide, CO2. So also D has one element and one compound. So the correct answer here is C. Water, which has hydrogen and oxygen, and carbon dioxide, which has carbon and oxygen. So that is a compound, a substance made up of two or more elements which are chemically combined. Question 5. In a class activity to classify mixtures, learners were given the following mixtures. The first one, Roman 1 is salt and sand. Roman 2, sugar and water. Roman 3, kerosene and water. And then Roman 4, milk and water. Then the question is asking, which two of the mixtures are homogeneous? Before we answer this question, it's very important for us to know what is an homogeneous mixture. An homogeneous mixture is a mixture which has particles which are uniformly distributed between the mixture or within the mixture. So homogeneous mixture must have a mixture is a mixture in which the particles in the mixture are uniformly distributed. The opposite of this one is what we call heterogeneous mixture. We have a substance called heterogeneous mixture. This one, in this mixture, substances are non-uniform. They are not uniformly distributed. So in this case, we want to identify a mixture in which particles are uniformly distributed. Look at this, salt and sand. These particles of salt cannot be distributed uniformly with sand. So in this case, the first one is not. Second one, sugar and water. If you mix sugar and water, you cannot be able to differentiate where sugar is and where water is. So this one is a homogeneous mixture. Kerosene and water. Kerosene and water. This one is an heterogeneous mixture because it forms two layers. Kerosene can never mix with water. So this one is not. Then milk and water. If you mix milk and water, it will be very hard for you even to separate the two. So in this case, this one is also a homogeneous mixture. So our answer in this case should be having sugar and water, that's Roman 2, and then milk and water, that is Roman 4. So our correct answer is B. Our correct answer is B. Question 6. During a class discussion on metals and non-metals, learners were asked to classify the following elements. The first one we have is calcium, second one is sulfur, the third one is phosphorus, and then the fourth one is sodium. Then the question is asking, which one of the following pairs of elements consist only of metals? So among the elements that we have up there, we want to identify a pair that consists only of metals. And now I want to give you a trick on how you can identify metals and non-metals. What you do, you write the electron arrangement of these substances. Remember, when you discussed the periodic table, you were told how to write the electron arrangement. So let's begin with calcium. Calcium is atomic number, this atomic number, and then we have electron arrangement. So we are going to list it here. So calcium is atomic number 20 in the periodic table. Electron arrangement is 2 for the first energy level, then 8 for the second energy level. These are 10. Then another 8 for the third energy level. These are 18. And then 2 for the fourth energy level. So in this case, we have 2 plus 8 plus 8, that is 20. 20 electrons. Remember, number of protons is equal to the number of electrons. Then the second one is sulfur. Sulfur is atomic number 16. It's atomic number 16. Then the electron arrangement will be 2, 8, 6. Then the third one is phosphorus. Phosphorus is atomic number 15. Electron arrangement 2, 8, 5. Then the last one in this case is sodium. Sodium is atomic number 11. Electron arrangement 2, 8, 1. Now, how can you use the electron arrangement to know either substance is a metal or a non-metal? Very simple. If it's a metal, the outermost energy level has electrons less than 3. And then if it's a non-metal, for a non-metal, the outermost energy level have electrons of more than or equal to 4, more than 4, not equal in this case, more than 4. So also the first one here for metals, less than 4. Less than 4, it means in this case it can never be 4. More than 4 in this case, it means can never be 4. So in this case, for metals, they have either 3 electrons in the outermost energy level, 2 or 1. For non-metals, it means they have 5 electrons in the outermost energy level, 6 electrons, 7 or 8. Now let's go to the table that we have here. The first one, calcium, has 2 electrons in the outermost energy level. Therefore, it falls under metals. So calcium is a metal. Then the second one is sulfur, has 6. In this case, it's more than 4. So in this case, sulfur is a non-metal. It's not a metal. Then the third one has 5. 5 in this case falls under non-metals. And then the fourth one has 1. So it means in this case, it falls under metals, 1. So in this case, the metals that we have is the one which Roman 1 and Roman 4, which is option A. Remember, for you to identify it's a metal or a non-metal, you just write the electron arrangement, and then you look at the outermost energy level. If the electrons are more than 4, then in that case, that's a non-metal. If the electrons are less than 4, then that is a metal. So like in this case, we are told to identify metals, then we look at the substances with less than 4 electrons in the outermost energy level. And in this case, calcium and sodium takes it. So the 7th question reads, the diagram below represents arrangement of particles in 3 substances as drawn by a learner during a lesson on states of matter. So this learner was learning states of matter, and remember states of matter, there are 3. The first one is solid, second one is liquid, then the third one is gas. So those are the 3 states of matter. So the learner drew this one. So the question is, which 2 of the diagrams represent the particles in air and in water? Then in this case, we should ask ourselves, where does air lie? Air lie in gas as a state of matter. Water lie in liquid. So in this case, let's see the characteristics that we can observe from this arrangement. The first one, the particles are very far away from each other. Very far away from each other. It means in this case, force of attraction between the particles is weak. And therefore, in this case, you can see the particles are randomly arranged or moving. Then the second one, we can see the particles are very close to each other. Then in this case, it means force of attraction between the particles is very strong. And then in this case, particles are arranged. They are arranged in a very regular shape and in contact with each other. The last one here, Roman 3, the particles are slightly close to each other. Slightly close to each other. Then in this case, it means the force is relatively stronger than the first one or the Roman 1. Then in this case, you can also see the particles are in a random arrangement. So this one, you can use these qualities to classify this into 3 states of matter. The first one in this case is going to be a gas because particles are very far away from each other. The force is very weak. The second one here is solid because the particles are very close to each other. The force is very strong. Then the third one is liquid. The particles are relatively close to each other. Force is relatively stronger, but the particles are still in a random position. So in this case, we want to place air, which is a gas, and water, which is a liquid. So we should go with an option which has which we have given as a gas, Roman 1, and the one that we have given as a liquid, Roman 3. So our answer should have Roman 1 and Roman 3. So the correct answer here for air, it is in gaseous state. And then that is Roman 1. And then for water is in liquid state, that is Roman 3. The eighth question, learners were controlling fire, which was burning a bush. Which one of the following actions could not control the fire? If you want to answer this question perfectly, then you need to know what we call a fire triangle. Fire triangle. Anything which is not in the fire triangle, it cannot be used to control the fire. So a fire triangle looks like this, where we have heat, we have fuel, and then we have oxygen. So if you want to control fire, then you need to control these three things. So in this case, we have different options. The first one, turn on the fire alarm. Does it appear on the fire triangle? No. So this one cannot control fire, and that is definitely our answer. Then the second one, cutting off oxygen. Oxygen appears in the fire triangle, so this one can control fire. Cutting off source of heat. Heat appears in the fire triangle. This one can control fire. Then the fourth one is moving fuel away from the fire. Fuel is part of the fire triangle. This one can control fire. So the question is asking which one could not control. The first one here, turning on a fire alarm, cannot control the fire. So let's move to the ninth question. Learners observed that water obtained from a nearby stream was not lathering easily with soap. So definitely they obtained what we call, the stream had what we call hard water. They suggested the following methods of making the water to lather. So they wanted to soften. They wanted to make this water soft water. So these learners obtained water from a stream. They realized that it does not lather easily with soap. So they wanted to make it rather easily with the soap. They wanted to soften this hard water. Then now, these are the options: boiling the water, filtering the water, adding washing soda. The question is asking, which of the method suggested by the learner could be used to make the water rather easily? So they wanted to make this hard water to go soft. But before we answer this question, it's very important for us to know what is hard water. Hard water. Hard water, this is water that contains dissolved mineral salts. Is water which contains dissolved mineral salts of magnesium and calcium. So any water whose constituents contains magnesium ions, which we write as calcium ions and magnesium ions, we call it hard water. And now, what are some of the methods which we can use to control or to remove this water hardness or to remove these ions? In this case, we can do what we call boiling. So we can remove water hardness by boiling. We can also use distillation, that is simple distillation. Then we can also use what we call sodium carbonate. We can add sodium carbonate, which we call washing soda. So sodium carbonate sometimes called washing soda. And then we can do what we call lime soda process, among other processes like ion exchange. We can do what we call ion exchange to remove water hardness. So this letter suggested these methods as a way of removing this water hardness. Which one could not? Now, in this case, they are asking which one could remove this water hardness, or which one could soften this water. The first one, boiling. Boiling, we have said, is one way of removing water hardness. So this one was correct. The second one was filtering. Filtering, we have not discussed it anywhere, so this one cannot remove water hardness. And then adding washing soda. Washing soda, which we have said is sodium carbonate, can remove water hardness. So in this case, the two methods which could remove this water hardness or make the water rather easily is boiling, Roman 1, and 3, adding washing soda. So Roman 1 and Roman 3, our answer is C. Question 11, the following are some of the changes that take place in day-to-day life. 1, water becomes ice. 2, fermenting of milk. 3, rusting of iron nails. 4, drying of wet clothes. The question is, which one of the following pairs consists only of physical changes? Before we answer this question, it's very important for us to know the type of changes that we have in matter. These two types of changes, one of it is called a physical change, and then the other one, we call it chemical change. Now, how can we identify if a process is a physical change or a chemical change? For physical change, there's no new substance that is formed. No new substance is formed. So if you want to know if a process is a physical change, then when that change takes place, no new substance is formed. For chemical change, a new substance is formed. New substance formed. And then the second property which you can use to identify a physical process is that no energy is given out. No energy is given out or absorbed. Then for chemical change, energy is given out. Energy is given out or absorbed. Then for another one, which we can use to identify, is that the mass of the substance does not change. Mass of substance does not change. Does not change. Then for chemical, mass of the substance changes. And then the fourth one is that the change is usually reversible. Change is reversible. So you can reverse this process. Then for chemical, change is irreversible. This one you cannot reverse. So in this case, let's look at the changes that we have been given and then identify if they fall under physical or chemical. The first one, ice becoming or water becoming ice. This one is a change of state. In this case, you have a liquid. You have a liquid. You are only changing it from a liquid state to solid. And then if you warm this solid, then it will become a liquid. So this one is physical. This one is a physical change. This is physical. And then the second one, fermentation of milk. If you ferment milk, are you able to reverse it to be milk which you can use to make tea? No. So this one is a chemical change. Then rusting of iron nail, where you have iron and then it rusts to become hydrated iron 3 oxide. In this case, this is a chemical process because it is changing completely and you can never reverse it back to iron nail or iron metal. Then drying of wet clothes. You are drying a wet cloth. You are only drying it so that water can move out. These are physical. These are physical change. So in this case, they're asking which one of these consists of only physical changes. Then it should be water changing to become ice. The first one, Roman 1. And then the other one is drying of wet clothes. The fermentation of milk and rusting of iron are chemical processes. So in this case, we need Roman 1 and Roman 4. That is B. So our correct answer here for substances which have undergone physical change is D. That is water becoming ice and drying of wet clothes. Question 12. During a lesson, learners discussed application of acids and bases. They listed the following application. 1. Manufacture of car batteries, manufacture of soft drinks, manufacture of toothpaste, and then manufacture of baking powder. So in this case, the question is asking which one of the following pairs of the applications listed are for the bases only. We want to see the pairs which consist only bases. So in this case, what we do, we have first to know what is an acid. And this is the best revision we can do. What is an acid? An acid, we define it at junior school level as a substance that reacts with a base to form salt and water only. Sometimes we define it as a substance that turns a blue litmus paper red. So an acid is a substance which can turn a blue litmus paper to red, and red remains red. And in fact, we should add that. And red remains red. And then a base, we can define a base as a substance that reacts with an acid to form salt and water. But in this case, let's define it as a substance that turns a red litmus paper blue. So a base is a substance that turns a litmus paper blue, and a blue litmus paper remains blue. So in this case, they are asking which of these substances are uses of bases only. In this case, manufacture of car batteries, we use sulfuric acid. So this one is not used in manufacture. It's not a use of a base. Manufacturing of soft drinks, we use carbonic acid. So this one is also not a use of a base because it's a carbonic acid. In manufacture of toothpaste, we use a base, and then in baking powder, we use also a base. So in this case, our correct answer should have Roman 3 and Roman 4. Our answer here is C. Then 13th question, during a class discussion on functions of the parts of a male reproductive system, learners identified functions of various parts of the system. The functions of tests. Its function is, the first one they have given us is produce hormones and sperm. The second one, transport sperm. This one definitely cannot. Produce sperm only. Then the third one, transport sperms and produce hormones. Transporting sperm is not a function of tests. So in this one is disqualified. The second one is also disqualified. So the one that is remaining in this case is produce hormones and sperms. This one is the correct one. And then because sperms or tests produce an hormone, which we're going to discuss later, then produce sperms only. This one is wrong. So in this case, our correct answer is A, produce hormones and sperm. Question 14, after a discussion on changes that take place in boys and girls during adolescence, Alana summarized the changes as shown in the table. Which one of the changes is correctly summarized? So in this case, Alana was summarizing changes that take place in boys and girls during adolescence. And the question is asking which of these is correctly summarized as a change that take place both in boys and girls. So let's look at A. In boys, hips become broad. This is wrong. Hips are for girls. Then in girls, hips become broad. So this one is okay, but this one is wrong. Then B, just widens. This is correct for boys. But for girls, chest widens. This is not correct. Then C, breasts enlarge. For boys, this is wrong. Then for girls, breast enlarge. This is correct. So D, pubic hair grows for boys, and for girls, pubic hair grows. So in this list, the one which is correct for both boys and girls is D, where pubic hair grow in both. Then question 15, the diagram below was drawn by Alana to represent the female reproductive system with parts labeled K, L, M, N. Use the diagram to answer the question 14 and 15. So as you can see, we have these parts. But before we answer the question or we read the questions, let's label this part. So this part called K is called a fallopian tube. This is a fallopian tube. Then this part called L is called ovary because it's one. Then M is called the uterus, and then N is called cervix. This is R. So now let's go to the question. Name the part labeled N, or the part labeled N represent this N here, which we have said is a suffix. Correct. Then question 16, fertilization takes place at the part labeled. Fertilization takes place in the fallopian tube. So part labeled K, which is A in this case. Question 17, at adolescence, boys and girls may experience frequent change in moods. The best advice for such adolescents would be, so the question is asking us the best advice that you can give to an adolescent boy or a girl. The first option they have given us, be sleeping less. This is wrong because adolescents should be sleeping more or have enough sleep. Avoid interactions. This one is not a good advice. Do physical exercises regularly. This one is correct. And then eat more energy giving food. This one is not correct because they have a lot of energy. So in this case, they should do physical exercises regularly. Then question 18, the diagram below was drawn by Alana to show parts of the human urinary system. This is a human urinary system with parts labeled P, Q, R, and S. Use the diagram to answer the question 17 and 18. Before we go to the question, let's label the parts, or let's name the parts that have been labeled. So in this case, P is our left, this is our left kidney. This is our left kidney. This one is right, of course. You should know how to label this one. This one is right kidney. And then Q is ureter. This is a ureter. Then we have this R as our urinary bladder. And then we have S as our urethra. So you should know the difference between a ureter and a urethra. So in this case, question 18, the part that stores urine temporarily is represented by a letter. The part that stores urine temporarily is this part R, which is a urinary bladder. So it is R. Then 19, the function of the part represented by Q is to this Q here. This one here, which we have called a ureter, its function is, let's see the option they have given us, filter salt and water, no. Filter waste products from the blood, no. Provide temporary storage of urine, no. This one we have said is for the urinary bladder. Provide passage of urine to the bladder, correct. So this part we call a ureter. It provides passage of urine from the kidney to the bladder. So question 20, the diagram below was drawn by a group of learners to represent the human skin with parts labeled T, U, V, W, and X. Use the diagram to answer question 20 and 21. So before we even answer question 20 and 21, let's label the parts that, or let's name the parts that have been labeled. Part T, this one here, is known as the epidermis. This is the epidermis. Epidermis. Then part U, this U is known as the air. Then part V, this part V here is known as the sweat pore. The sweat pore. And then we have part W. Part W in this case is known as sensory nerve ending. Nerve ending. Sensory nerve ending. And then finally, we have part X, which we call the sweat gland, because it's one in this case, sweat gland. Then now the question 20 asks, the part of the skin that produces sweat is represented by letter. The part of the skin that produces sweat is represented by letter. So the part of the skin that produces sweat is called the sweat gland. Sweat gland in this case is in X. So in this case, our answer is B. The sweat gland is the one that produces sweat. Then question 21. Which one of the following is the function of the part labeled T? The part labeled T is the epidermis, and the function of the epidermis is to protect the inner part of the skin from external injury. So in this case, let's read the option that we have been given. The first one is protection against physical injury. This one is correct about the epidermis. Then the second one, insulating against heat loss. This one is not correct. Then supply of blood, not correct. And then production of air, this is not correct. So the correct answer in this case is to protect against the physical injuries. Then question 22, the human digestive system has various parts that perform different functions. In which one of the following parts of the system does absorption of water takes place? Remember, water is not part of the food, or water is not digested in a human body. So in this case, which part of the body absorbs water? Stomach? No. In the stomach, digestion takes place of starch. So this one is not where water is being absorbed. So this one is not. Large intestine, correct. That is where water is being absorbed. Then we have the mouth. No. Mouth, we have starch being digested there. Small intestine. No. This is where proteins get digested. So the correct answer in this case is B. Large intestine. That's where we have water being absorbed during digestion. Then The 23rd question, human beings have different type of teeth. Each type has unique structure suited for its functions. A learner observed a model of a tooth that had sharp edge. So the tooth that the learner observed had sharp edge and was chisel shaped. The function of the tooth is likely to be, so in this case, before even we know the function, we need to understand what type of teeth was the learner or did the learner observe. In this case, the type of teeth that has or which have a chisel shaped and is very sharp, in this case we call it incisors. So this is incisors. Incisors is the one which is chisel shaped and it has a sharp edge, so it is incisors. So, and the function of incisors is cutting and biting food. So in this case, the correct answer here is cutting and biting. Crushing, this is the function of molars and premolars. Chewing, this is the function of molars and premolars. And then tearing is the function of canines. This is the function of canines. Question 23, a medical officer gave a talk on health lifestyle that promotes kidney health. Which one of the following could not? So in this case, our keyword is could not be included in the talk as a healthy lifestyle that promotes a kidney health. So in this case, the four options that we have, three of them are the one that promotes kidney health, but one does not. So in this case, we are supposed to identify the one which does not represent a kidney health lifestyle. So the first option we have is eating a balanced diet. This one is correct. When you eat a balanced diet, your kidney health will be good. Drinking plenty of clean water. Here the keyword is clean water. This one is correct. Getting enough sleep. This one is also correct. Then eating sugary foods. Eating sugary foods is not a health lifestyle. So in this case, this one does not promote healthy kidney. So in this case, our answer is D. Eating sugary food, eating salty food, they don't promote a healthy lifestyle in promoting kidney health. Then question 24 reads, during a class experiment on properties of magnets, a learner freely suspended a magnet as shown in the diagram below. So we have a diagram where we have a wooden stand, a thread, we have a suspended magnet. Then the question is, which one of the following is the correct direction the bar magnet could align to? After this bar magnet has been suspended, it has been swinging. Now, when it settles, where does it align to? Before we answer this question, let's look at how a magnet looks like. A magnet has two poles. We have North Pole and South Pole. And then this same magnet has what we call magnetic field. So this is a magnet. This is a magnet. The same magnet has magnetic field where the area around a magnet where the magnetic influence is felt, that's what we call a magnetic field. So this magnetic field is represented using what we call magnetic field lines, which originate from North Pole to South Pole. So these are the magnetic field lines. So in this case, if you suspend this magnet and you swing it, it will rotate and then settles in a north-south direction. Why? In the Earth's surface, we have a giant magnet. This is the Earth. This is the Earth. So it also has a giant magnet. It behaves like a giant magnet. So it also has North Pole. It has North Pole and South Pole. So in this case, the Earth also has its own magnetic field lines, which originate from North Pole to South Pole, like that. So when you suspend a magnet, it will swing in such a way that it will settle while the magnetic field lines are oriented all aligned with the Earth's magnetic field. So we have the magnet and then we have the Earth. So it will swing until it aligns itself in such a way that it's in line with the Earth's magnetic field line. So in this case, north pole of the magnet will settle in the north part of the magnet, and then south pole will settle in the south pole of the magnet. So now let's look at the question. Which one of the following is the correct direction the bar magnet will align to? In this case, northeast, southwest, this is wrong. East, west, this is wrong. North, south, this is correct. And then northwest, southeast, this is not correct. So this magnet will align itself in a north-south direction. And this is because it aligns itself with the Earth's magnetic field. Question 25. In an activity to identify magnetic and non-magnetic material, learners put a certain object in a box and placed the box near a bar magnet as shown in this diagram. Then, so here we have a magnet which has north pole and south pole, and mind you, the red part is the north pole and this one is south pole, the blue one. Then we have a box here. So the question is, the box was observed to move in the directions shown by the arrow. So in this case, this magnet moves toward the magnet. This box moved towards the magnet. Then the object inside the box was likely to have been. Now, if this magnet attracted, when it moves towards the magnet, we say it has been attracted. And magnets only attract magnetic material. In this case, the material which is inside the box must be a magnetic material. So this one must be a magnetic material, because we define a magnetic material as a material which can be attracted by a magnet. So in this case, let's look at this. The first case here we have is silver coin. Silver is not magnetic. Iron nail, iron is a good magnetic material. Gold is not a magnetic material. Wooden rod, wood is not a magnetic material. So in this case, the object inside the box is likely to be iron nail, because iron is a good magnetic material, which we call a ferromagnetic material. Question 26. Learners classified sources of electricity into renewable sources and non-renewable sources. Which one of the following combination of sources of electricity was correctly classified by the learners? So in this case, before we can answer this question, let's define what we mean by renewable sources and then non-renewable sources. Non-renewable sources, and then give examples depending on what they listed here. Renewable, we define them as sources which can be easily and naturally replaced. Examples we have in this case where they listed, we have first one, we have wind, then we have geothermal. Geothermal is a renewable. We have hydroelectric. Hydroelectric is renewable. Then we have solar, is also renewable. We have tidal, is also renewable, tidal waves. And in this case, we have biomass, it's also renewable. Then let's define non-renewable. Non-renewable, we define them as sources which cannot be easily replaced. Examples in this case, we have coal, and then we have natural gas. So let's now go to the question. Which of these combination is correctly classified? Under in A, renewable, we have geothermal, which is correct. And then non-renewable, we have coal. So this one is correct. Second one, B, We have wind as renewable, which is correct. Hydroelectric as non-renewable. This is wrong. Hydroelectric is renewable. Then C, we have natural gas as renewable. This is wrong. These are non-renewable. Then non-renewable, we have solar, which is also wrong. Then D, we have tidal waves as renewable, which is correct as a renewable source. And then we have biomass as non-renewable, which is wrong. Biomass is a renewable source. So in this case, our correct answer is A. The correct combination is that geothermal is renewable and coal is non-renewable. That is the combination which is correct. Then question 27, in an experiment to demonstrate the flow of electric current, learners connected materials to make simple electric circuits. Which one of the following diagram represent an electric circuit in which the bulb will lit or will light? In this case, for a bulb to light, then it must be a complete circuit. A complete circuit in this case, it means the switch is on, and then we have a battery, we have a bulb, and then we have a good conductor as the connecting material. So let's look at the first diagram. We have a battery. The circuit is complete, there's no gap. Then we have wood. Wood is a poor conductor. It's a poor or a non. Let's use the word non-conductor. It's a non-conductor. It's a non-conductor of electricity. So in this case, the bulb will not go on. Then the second case, we have a battery, correct? We have a bulb, we have a wire, the circuit is complete, but we have plastic. Plastic is also a non-conductor of electricity. So in this case also, the bulb will not go on. Then the third one, we have number C, we have a battery, the circuit is complete, we have a bulb, we have a connecting wire, then we have a nail. A nail is a good conductor because it's a metal. So in this case, this is a good conductor of electricity. So in this case, the bulb will go on. And then in the last, that's number D, we have a battery, we have a connecting wire, we have a bulb, but we have a glass rod. These are non-conductor. So in this case, the place or the circuit in which the bulb will go on is this C, where we have a nail, and the nail is a good conductor of electricity. In question 28, learners identified safety measures during a discussion on handling appliances. Which one of the following measures identified by the learner is safe? So what we have, the learners listed several measures when you are handling appliances at home. Now, which one is safe? We want to see the one which is safe. The first one, operating electrical appliances with dry hands. This one is a safe way of handling appliances. Then the second one, connecting an appliance to electricity when cleaning it. This is wrong. You cannot connect appliance while cleaning it. Then the third one, inserting foreign objects into electric shocks or into electric sockets. This one is wrong. It can lead to electric shock. Then D, overloading power sockets with many appliances. This one also can lead to the jam of the electric appliances or sockets. So in this case, the correct measure of handling appliances is operating electrical appliances with a dry hand. So our correct answer is A. Question 29. During a class discussion on appliances used in day-to-day life, learners listed the following appliances. 1. Air conditioner. 2. Fireless cooker. 3. Thermos flask. 4. Washing machine. The question is, which two of the listed appliances use electricity to perform their functions? Let's look at the list. 1 is an air conditioner. So this one is correct. It uses electricity. Second one is fireless cooker. This one does not require electricity. Then third one is a thermos flask. This one does not require electricity. Then washing machine. This one needs electricity. In this case, our option A is 1 and 2, that is air conditioner and fireless cooker. This one is not. Then B is 2 and 3, that is fireless cooker and thermos flask. This one does not require electricity. Then 3 is 1 and 4, that is air conditioner and washing machine. This one is correct. It requires electricity. Then the fourth one is the D is Roman 3 and 4, which is thermos flask and washing machine. This one is wrong. So in this case, our correct answer is C, air conditioner and washing machine. Question 30, curved mirrors are used in day-to-day life for different purposes. Learners discussed and listed the following as applications of curved mirrors. Remember, curved mirrors, we have two types of them. One, we have concave, and then two, we have convex mirrors. So in this case, they discussed the two of them. Now, some of the discussion that they had is that they are used as security mirrors in supermarkets. This one is a function of a convex mirror. Then the second one, they are used as motor vehicle side mirrors. This one is also a convex mirror which performs this function. Then the third one, they are used as car headlights. Car headlights, we use concave mirrors. And then fourth is solar cooker. Solar cooker, because they have to converge rays, then it's a concave. Then now let's go to the question. Which two of the uses are correct only for the convex mirror? So in this case, the correct one for the convex mirror is as used as security mirrors in supermarkets because they have a wide field of view, and also in motor vehicle side mirrors. So the reason why we use this convex for these two purposes is because they have a wide field of view. We will discuss this one in the next video. So in this case, the correct one is Roman 1 and 2, which is D. They are used as security mirrors in supermarkets and also used as motor vehicle side mirrors. For car headlights and solar cookers, we use concave mirrors because they have a high ability to converge rays. So let's move to section B, and this section we are going to handle structured questions. Structured question in this case, it's either you are stating, you are describing a process, you are discussing, you are explaining, and many other questions that we are going to see. So question 31A, during a class activity, learners determine the temperature of water using a thermometer. Identify two basic skills in science applied in this activity. How do you identify the skills applied in an experiment? In this case, we look at the things that they are handling. They are handling a thermometer. So handling a scientific apparatus, that skill, we call it manipulative skills. Manipulative skills. This is where a learner handle scientific apparatus. In this case, they use a skill we call manipulative skills. The second one is after handling this apparatus, they do what we call observe. They have to observe. So we have observation skills. They have to look at the thermometer, they have to measure or to read the scale. In this case, this is where the learner is making observation by either seeing, hearing, or even testing. Then another skill that the learner will get in this case is what we call measurement skills. Measurement skills, because these learners are going to read the scale. So in this case, for measurement skill, the learners are going to determine or to read the scale. So in this case, they will read the scale. In that case, they have used a scale called a measurement scale. Let's go to the next question. Question B, that one, state the international system of unit, SI unit. They have not used unit, they have used unit of temperature. The SI unit of temperature is Kelvin. Kelvin with capital K because it's the name of a person. So it is Kelvin. That is what you are supposed to state. Don't give K. K is a symbol of the SI unit. And in this case, you are asked to state. So in this case, it's Kelvin. And don't add S because it's not unit, it's a unit. Then question 32, the diagram below represents a setup used by learners to separate components of a mixture. So in this case, we are doing separation of substances. So we cannot see the diagram is a distillation, but we cannot distinguish which part. We're going to see that later. So in this case, we have a mixture itself. We have a source of heat here. We have a beaker, and this beaker inside it has a distillate. Then we have a Lebesgue condenser with a water in, water out. We have a thermometer. But in this case, since it's distillation and we have two types of distillation, we don't have a fractionating column. So in this case, we lack a fractionating column. And this is the one which is going to give us the name of the type of separation that we're going to use. So in this case, since we have two types of distillation, we know the process is distillation. So we have fractional distillation, and then we have simple distillation. The difference between the two is that fractional has a fractionating column, but this one lacks a fractionating column. So in this case, since this one does not have a fractionating column, then this one is simple distillation. This is simple distillation. That's how you identify it. If it had a fractionating column, then it would be fractional distillation. Now, what is simple distillation? Simple distillation is a process of separating solid liquid mixtures. And in this case, the solid must be soluble. The solid must be soluble. So this method is only used to separate solid liquid mixture, not liquid mixture. It's used to separate solid liquid. In fact, we can include the word homogeneous. Solid liquid homogeneous mixtures. Homogeneous in this case, it means it is soluble. The solid or the solute is soluble in this solvent. So in this case, we have a solution. So in this case, name two homogeneous mixtures that can be separated using this method. In this case, we have said it's a solid liquid mixture and it should be homogeneous. Then in this case, our first case is salt as our solute and water. Salt and water. Then the second one is sugar and water. These two are soluble. So this salt is soluble in water. So in that case, you will have a solution. Also, sugar is soluble in water. Then you have a solution. So these are the two possible homogeneous mixtures that can be separated using this method. Do not confuse this one with fractional distillation. We will discuss it later. Question 33, describe how one can recover salt from salt solution. So in this case, we have just said you can separate salt from salt solution by using simple distillation. But in this case, for simple distillation is when we are interested with both the solute and the solvent. But in this case, we are only interested with salt. So we can use a method which we call evaporation method. And when you are now told to describe, first you must tell the apparatus that you are going to use, then how you are going to use it, how you are going to separate, and then how you will obtain the final result. Like in this case now you can say you pour the mixture, pour the mixture into an evaporating dish and into an evaporating dish. Then the second point you can tell us, heat the dish or the mixture, heat the mixture gently. In this case, you can use a water bath so that heat the mixture gently so that the water can start evaporating, because we are not interested with water. So in this case, the water will start evaporating, leaving behind the salt. So the third point, while you are describing, you can say keep heating, keep heating, keep heating until most of the water evaporates. So in this case, this is what we call a saturation point. So you heat until this saturation point. You heat until saturation point is reached. Saturation point is a point where the water have gone and the part which is remaining can now crystallize. And then lastly, you can tell us, let the salt crystals. So after you have hit the saturation point, of course, you have to leave the apparatus to cool, And then after that, now you remove or you let the crystals dry, then you collect them. So you can tell us, let the crystals formed dry and collect them. So for you to describe this, first you must begin with an apparatus. You put it in an evaporating dish, and then you tell us what you do. You heat the mixture gently. You don't heat strongly. When you heat strongly, then you are not going to obtain crystals. So you heat gently so that the water can start evaporating, and then you keep heating until most of the water evaporates. And in that case, we call that point a saturation point. And then you leave the apparatus to cool. Then you let the crystals to form. Now, these crystals that have been formed, you allow it to dry and then you collect it. So in that case, you have described. Let's go to the next question, that is B. The question is asking, describe how you can separate alcohol from a mixture of water and alcohol. In this case, water and alcohol, they form a mixture which we call a miscible mixture, where a liquid and a liquid mix to form an homogeneous mixture. So this one is very hard to separate. So for you to separate them, you have to take advantage of their difference in boiling point. Like in this case, water has a boiling point. Water, let me use a different ink here. Water has a boiling point of 100 degrees Celsius, while alcohol has a boiling point of 78 degrees Celsius. So this difference in boiling point, but they are very close, is what we use to separate this. So how can you describe this process? So in this case, as usual, first you must mention the apparatus we used. Like in this case, you can say heat the mixture, carefully in a fractionating apparatus or in a fractional distillation apparatus. So you heat this mixture in a fractional distillation apparatus. Then in this case, of course, because alcohol, now in this case you can come and say alcohol has a lower boiling point. It has a lower boiling point, hence it will boil fast. It will boil fast, leaving water behind. Now that is not enough because you are describing, then you must tell us what will follow. Now the vapor, the alcohol vapor will condense inside the Levy condenser. The alcohol vapor will condense in the Levy condenser, hence collected as a distillate. In that case, you have collected alcohol as a distillate on the other side. Since in this case we are not interested, how do you collect alcohol from a mixture of water and alcohol? So in this case, since you have collected a distillate on the other side, you have answered the question. Now let's move to the next question, question 34. Question 34A asks, describe or learners who are provided with colored flowers to prepare an acid-base indicator. So this is a flower extract acid-base indicator. Describe how the learners could have prepared the indicator. Describe how the learners could have prepared the indicator. So in this case, already they have been given the flowers. So in this case, you mention where you put these flowers. So in this case, you can begin by saying, put the flowers inside a mortar. This is the apparatus in this case, and then and grind using a pestle. That is the first point. Then the second thing that you should tell us, add small amount of water, small amount of water while crushing. So you are crushing these flowers while you are adding small amount of water. In this case, to dissolve the color, because we are interested with the color, be used as an indicator. Then in this case, you can continue and say, after crushing now, in this case, filter the mixture to obtain a colored mixture, not necessarily water. The water that you added, now it will form a mixture. To obtain a colored mixture, filtrate. In this case, you have removed the solid particles of the flower, so you filter. And then in this case, now you can use this one. Now in this case, after you have done that, you have obtained your indicator. Then now you can use, now when you have added this one, you can use this one, use this filtrate, as your indicator. Use this filtrate as your indicator to test whether a substance is basic or it's acidic. Then the question 34B asks, a farmer realized reduced crop production on his farm. He took samples of the soil for testing. It was found that lime should be added. Mark this one. Lime should be added to the farm based on the knowledge of acid and bases. Explain the purpose of adding lime to the farm. Adding lime to the farm, in this case, when we talk about lime is basic. Since lime is basic, if you add it to the soil, in this case, it's going to increase the soil pH. Increasing the soil pH, in this case, it means it will make the soil basic, because when you have lower crop production, it means your land is more acidic. But now in this case, we are told to use the knowledge of acid and bases to explain the purpose of adding lime to the farm. Explaining in this case, you can simply tell us lime is basic. Lime is basic. Adding it reduces soil acidity. Reduces soil acidity, hence increasing production. But you can leave it at that point. Another important thing is that lime improves soil fertility. Lime improves soil fertility because lime contains calcium. Soil fertility. We can have other things like it improves microbial activities and it also enhances crop growth, but you can give just 2 for the purpose of scoring. Question 35. The flow chart below shows 2 human excretory organs and their products. In this case, we have 2 excretory organs, that is the skin, and then 2, we have the kidney. Now, these 2 excrete water. The kidney excretes excess water, also the skin excretes excess water. But now, what other products does the skin excrete? And what other excretory products does the kidney excrete? What we know, the main product of excretion from the skin is what we call excess salt. And then for the kidney, the main excretory product apart from excess water is urea. Now let's go to the question. Name the likely excretory products labeled G and H. G is excess salt, and then H is urea from urine. Then question B, during a talk on sexually transmitted infections, STI, by a medical doctor to learners, the doctor discussed signs and symptoms of gonorrhea and ways in which it can be prevented. The first question, state 2 symptoms of gonorrhea in male that the doctor could have talked about. Some of the symptoms that the doctor could have talked about gonorrhea is that tenderness. One, we have tenderness and pain in testicles. The second one, another symptom that he could have talked about is painful urination. The third one that he could have talked about is yellow or green discharge. Then, of course, he could have talked about inflammation of the foreskin. Then question Roman 2, name 2 other sexually transmitted infections the doctor is likely to have mentioned. Other sexually transmitted infections. One, he could have mentioned the common HIV and AIDS. Then he could also have talked about syphilis. The spellings here are very important. Then number 3, he could have talked about candidiasis. And then, of course, he could have talked about trichomoniasis. Those are some of the sexually transmitted infections that the doctor would have talked about. Of course, we have other more sexually transmitted infections. So question 36, the diagram below shows a setup used by learners to demonstrate a certain process that takes place in a living things. So in this case, you can see we have a setup at the beginning of the experiment and at the end of the experiment. We have a peeled potato, then we have salt crystals inside. We have a cavity, and then we have water outside the peeled potato. Then we have some at the end of the experiment, we have few less water outside, and then most of the water has moved in. So from what you can see in this case, this is a process called osmosis. This is osmosis. And what is osmosis? We define osmosis as a movement, or as the movement, as the movement of water molecules from a region of high water concentration. High water concentration, in this case, is uh, less concentration of the solution. In this case, we move from high water concentration to a more, or to a less water concentration, to a less water concentration region. So in this case, we have to identify at the beginning of the experiment where we have high water concentration and then where we have low water concentration. Like in this case, inside this, at the beginning of the experiment, this peeled potato, here we have low water concentration. Then outside we have high water concentration. Therefore, since this process is osmosis, and then because we have seen inside now, at the end of the experiment, there's more water there, then this one is osmosis. And in this case, water moved from outside of this peeled potato to the inside of this peeled potato in a process called osmosis. So now you are told now to explain the observation, why water moved from outside to the inside. So in this case, what you say, you can use the definition of osmosis, or just say at the beginning of the experiment, let's write at the beginning, at the beginning of the experiment, of the experiment, of the experiment, there is more water concentration outside than inside the peeled potato, than inside the peeled potato. Therefore, water moved, therefore, water moved from a region of high water concentration to a region of less or low water concentration through osmosis. Remember, outside there is high water concentration, it means there is less salt. Inside there is more salt, it means there is less water. So in this case, through osmosis, water moved from a region of high water concentration outside to a region of less, or to a region of less water concentration in the inside. Then question B, a member of parliament, MP, donated sanitary towels which were only given to girls in Form 3 and not those in Grade 2. Explain why only Form 3 girls were given the sanitary towels. Now, in this case, we have to look at the two cases. The Form 3s, they are over 11 years or 12 years. And then for Grade 2, they are only about 6 to 7 years. So these two are totally different on developmental stages. Form 3s have reached what we call the menstrual cycle period, while Grade 2 have not. So in explaining this, you can say it's because grade 2 learners, grade 2 learners have not started experiencing have not started experiencing menstruation, hence are not in adolescence stage as compared to form 3s. So in this case, you simply tell us the grade 2, they are not experiencing menstrual cycle or menstruation because they are not in adolescence, while form 3s are experiencing menstrual cycle because they are in adolescence. That's why they are given the sanitary towels. Then question 37, during a nature walk to study adaptation of flowers to wind and insect pollination, learners observed a dull-colored flower with small petals. So in this case, the keyword here is dull-colored flower and then small petals. Dull colors, they cannot even attract insects. Then they have very small petals, the one that receives the pollen grain. So in this case, it means the mode of collection, not even petals. Yeah, in this case, the petals are the one that attracts. So in this case, the mode of pollination is wind, because dull, it means it cannot be influenced by insects. So state the likely agent of pollination for this flower. In this case, it is wind. It is wind pollination. Wind pollination. That is the mode of pollination in this flower. Then question 2, state 2 other adaptations the learners may have observed on the flower. What are some of other adaptations that they could have observed apart from dull-colored flowers with small petals? So in this case, they could have observed something like they have large and feathery stigma. They have large and feathery stigma. They have large and feathery stigma hanging outside. Hanging outside. That is another adaptation that they could have seen so that they can receive that pollen grain at any time. Then another adaptation is that anthers are layer. Anthers are layer and loosely attached so that they can cross-pollinate easily, or they can give the pollen grain easily. Then question 38, a girl was advised to reduce amount of cosmetic she used on her skin. Explain how excessive use of cosmetics could affect the excretory function of the skin. In this case, we have to know what are these excretory products from the skin. The excretory product from the skin, one is excess water, and then in this case, we also have excess salt. So if you use excess cosmetics like makeups, they can block the pores, and in that process, it can prevent the flow out of this water and salt, and that one has an impact on the excretion of wastes, like in this case, salt and also water, which can prevent regulation of temperature. So in this case, we can say the excess use of cosmetics blocks the pores, hence preventing the removal of wastes and sweat from the skin, and this affects the skin's ability to regulate temperature. So you can just answer it as simple as that. So the second question, question 39, during an activity to investigate sources of waves in the environment, learners produced waves by plucking a string to vibrate. List two other sources of waves that belongs to the same group of waves as the one generated by the learner. So in this case, we are producing waves by plucking a string. In this case, it means these waves that we have produced requires a material medium for propagation. And the waves which require material medium for propagation are called mechanical waves. So this question requires us to list other sources of mechanical waves. Other sources of mechanical waves, you can get them by swinging a rope. In this case, you will form a transverse mechanical wave. Then you can also produce another mechanical wave by beating a drum. Beating a drum, in that case, it produces sound wave. Sound wave is an example of a mechanical wave, and you can also obtain them from a slinky spring. You can obtain mechanical waves from a slinky spring. So another question, B, during a lesson, learners observed images formed by concave mirrors with objects at different points. State the characteristics of an image formed by a concave mirror when the object is at infinity. In this case, I want us to draw a very brief diagram and where we are going to have an object at infinity. So in this case, we have our principal axis like that. Then we have our mirror. In this case, we have convex. These are convex mirror, not convex but concave. This is concave because the reflecting surface is facing the object. This is a concave. The reflecting surface is curved. In this case, we can have our focal length and then the principal focus here. And then, of course, we can have our center of curvature here. So this is our C, this is our F. Then in this case, they are asking if the image is at infinity. Image at infinity brings in what we call marginal rays. Marginal rays, these are rays which are parallel to each other, but not parallel to the principal axis. They come from a very far distance, so we cannot locate the position of the object. So these rays, they converge at the point which we call the focal plane. So they will converge at the focal plane. The focal plane is a plane which lies at the focal point. If I can draw a virtual focal plane like that, so in this case, if these rays come, they will all converge at the focal plane, and that's where the image will be formed. Excuse me. That's where the image will be formed like that. So this will be the tip of the image formed. The image will be formed like this, and now that will be the tip. So the image will be facing upside down like that. So in this case, these are the rays. they are asking us to give the characteristics of the images formed from the object at infinity. So the object is from this point. Is the object, then the image is formed at F. So in this case, one of the property is that the image is formed at F. Another property is that the image is upside down. Image is upside down. Another property, upside down. Another property that we can give, the image is real because it's formed in front of the mirror. Image is real. And then, of course, that is enough for now. We cannot give, maybe the image is larger than the object. We don't know where the object is. The object is from infinity, where we cannot describe it. Let's go to question 40. During an experiment on properties of magnets, a learner brought a magnet 1 close to the north pole of magnet 2. So we have magnet 1 and we have magnet 2. This magnet 1, this magnet 2, as shown in the diagram below. The learner observed that magnet 2, this magnet here, moved in the direction shown in the arrow in the diagram. So this magnet 2 here moved in this direction. This is the direction shown in the diagram. The magnet moved away from the magnet which is coming. Now the question is, identify the pole of magnet 1 that was brought close to magnet 2. Magnet 2, as you can see, the pole which is there is north pole. The part which is moving here is north pole. And then the part which is coming is repairing because that magnet is running far away from the magnet which is coming. So in this case, these are repulsion. Therefore, the magnet which is coming with a north pole also, because like poles repel and unlike poles attract. But in this case, there's a repulsion. Therefore, it means identify the pole of magnet 1 that is brought. In this case, it's north pole. So it's north pole which is brought close to the north pole of magnet 2. Then another question, question 2. Give a reason for your answer above. In this case, the reason you give is that the magnets repelled. In this case, you can now state even the law of magnetism. Unlike poles attract, while like poles repel. So in this case, you can say like poles of a magnet repel. So in that case, you have given a reason for your answer above. So question C and the last question, the diagram below shows a waveform drawn by a researcher during a study of properties of waves. So in this case, we have a wave. We have to identify this wave. Is a transverse wave. The reason why it's a transverse wave is because the displacement of medium particles is at right angle to the direction of propagation of the wave. So that's what we call a transverse wave. Transverse wave is a wave in which the displacement of medium particles is 90 degrees to the direction of propagation of the wave, and that's exactly what we have here. So in this case, another thing that we have to identify is the graph, the type of graph that we have. We have a graph of displacement distance graph. In a displacement distance graph, this case, of course, we have this part which we call a crest. Then we have this lower part which we call a trough. A crest is the highest point in a wave, and then a trough is the lowest point of a transverse wave. Let me write this one at a separate place here. This a trough. So in this case, we have the distance from a crest to crest. Like in this case, they have labeled it J. We call it a wavelength. So the part labeled J is called wavelength, when it's a displacement distance graph. Sometimes we have a graph like that. Let me draw it here very quickly. We have a graph like that, and then instead of this displacement distance, this one will be displacement, and then this one can be time. When it is displacement time, then the from here to here, it marks what we call periodic time t. But now we don't have this one. We have this one, which is a displacement distance graph, where J now represents the wavelength of this wave. And again, this maximum displacement of particles from here to here, we call it an amplitude. Amplitude is the maximum displacement of particles from the mean position. So that will mark the end of this paper, the revision of this paper. In the next video, we will discuss paper 2, that is practical of this same Knec exam paper.